Alright, today in calculus we'll be talking about the introduction to calculus, limits and their properties. Okay, so calculus came about because of the idea of how do I know when something has an instantaneous velocity, and it came about because a lot of physicists at the time were trying to calculate not average velocity but instantaneous velocity at a certain point. And they basically kind of found some interesting stuff with the math. Okay, now the warm-up, the introduction for this part is something you don't need to do, but it's something you need to talk about, especially because it is a tough thing. So we're going to take a look at each one of these in its own entirety. Okay. Alright, what does continuity mean to you? Now, if you looked at the actual function, continuity should mean something that is continuous, that I like to think of it as the point of when am I picking up my graph? When am I picking up my pencil when I'm drawing my graph? Okay, so that's my definition of continuity, but continuity means you can draw the entire graph and you can continue on forever and not have an issue with it. Okay, now the graph below that I'm looking at on the warm-up page, which is page 6 of lesson 1, is just taking a look at this part. So here, let me bring it over here. Oh, come on. There we go. Okay, he's taking a look at this actual graph right here. And the question is asking this. Look at the graph below, identify the portions where you think the function is continuous and describe these portions. So I think it's continuous from this furthermost left point, and it's a nice smooth curve until it gets to this furthermost right point. And then all of a sudden it skips this area between d, the difference in the function, and x, the initial point, and then it skips this area and starts again as a function. Okay, and it's just on this part. So I would say it's not continuous on the whole, but it's continuous from here to here, from here to here, and it is continuous at this point if you approach from the right. Well, you can't really approach it from the right. I would say it's got a point. It's got a point continuity. It doesn't have a line continuity type thing. Okay. Basically, what is happening is that if I take my pencil and I draw along the line, I have to pick it up here, put a point, pick it up, and put it back here. So wherever I have to pick up and then put it back, that is where I've defined as discontinuous or non-continuous. Okay? Alright? Now, if you were actually able to make this whole thing continuous, you would have to do a smooth curve, bring it up, bring it down, and then bring it back up again. So the other thing is, too, is continuity doesn't want exact, it doesn't want harsh angled lines. It doesn't want sharp corners. It wants nice smooth corners that work like this. Okay? So that's just some interesting stuff that you can look at it. Can you create a portion that includes the point where f is not continuous? Yeah, you can mess around with a lot of stuff like that. So basically, in introduction to calculus, limits and their properties is what is continuity of a function, how does it look as a graph, how does it look as a function, and another thing too is you need to know your domain and range. So if you do not know your domain and range, you need to get that down now, because domain and range are going to be two of the toughest things you're going to have to struggle through if you do not have it already. Okay? But we'll talk more about the graphs and their models real soon. All right, thank you.